Excuse me. Here are questions 3 and 4 of your review, the stoichiometry questions. So those two questions. Question 3 says you have 11.2 moles of water produced. So now we're using the equation. Okay, 11.2 moles of water produced. It wants to know how many moles there would be of carbon dioxide would also be produced with it. How many moles of oxygen did we have to use to get those 11.2 moles of water? And how many moles of the C7H16 would we have had to use to get those 11.2 moles of water? So if we start with 11.2 moles of water, again, whenever we start with moles, go directly to our mole ratio, okay, from the equation. So our ratio is for every 8 moles of water, which would go on the bottom, so our labels cancel. For every 8 moles of water that are produced in the reaction, there's 1 mole of C7H16 that was used. So we're just taking 11.2 right out of that. These two labels cancel, we're left with moles of what we wanted to have. So that is 1.4 moles of that. It's called heptane, by the way, the C7H16. Same thing, I can start with this number now, or I can start with 11.2, it makes no difference. If I say I have 11.2 moles of water, again, my ratio now, in this case, is going to be for every 8 waters, there's 11 oxygens, if I'm going to that. So again, for every 8 waters, in moles, I'm not writing the word moles, but for every 8 moles of water, there's 11 moles of oxygen. Those cancel. And we're left with 15.4 moles of oxygen. If we're doing the CO2, for every 8 moles of, for every 11.2 moles of water, and the ratio is for every 8 moles of water, there's 7 moles of CO2. Again, if we know one thing, in this case we only knew the moles of water that were produced in the reaction, we can figure out moles of each thing or grams. I can convert these to grams also if we need to know that. That's question number 3. Question 4, you have 175 grams of the heptane. So we have 175 grams of this. 175 grams of that. And it wants to know how many moles of water are produced. So we're going to moles of that. So again, make a little mark where you're going from and to. Starting with heptane, going to moles of water. So we got our 175 grams. So we need grams in the bottom for a mole. Again, I would write down what you have a mole of. In this case, it's a mole of C7H16 we're trying to figure out. So from the periodic table, 12 times 7 is 84, plus 16 is 100 grams for a mole. Relate our two things. Our ratio is for every 1, there's 8, 1 going on the bottom. So for every 1 mole of C7H16, there's 8 moles of water. And stop there. It wants to know moles, so we're done with that. Multiply your top numbers, divide by the bottom. It's 14 moles of water.